Okay, today we're going to start Chapter 7 notes. So we're going to talk about sampling distributions. So let's start with the parameter. So a parameter is a number that describes some characteristic of the population. And then remember that we use Greek symbols to represent these. Usually, the parameter is not known, and so we use the statistic to estimate the parameter. So a statistic is a number that describes some characteristic of a sample. So let's look at and review the symbols for the mean of a parameter, which remember is mu, and the statistic of mean is x bar. And then variance, remember, is sigma squared, and statistic is s squared. Standard deviation is the square root of variance, so that would just be sigma, and that would just be s. Proportion is p, and statistic is p hat. So the proportion one is the only one that doesn't have a Greek symbol. So the statistic part just gets a p with a hat on it. All right, so let's look at this example. Identify the population, the parameter, the sample, and the statistic in each of the following settings. A pediatrician wants to know the 75th percentile for the distribution of heights of a 10-year-old boy. So she takes a sample of 50 patients and calculates Q3 equals 56 inches. So I like to kind of underline what's going on here in the problem. There's our distribution, 50 patients, Q3. So Q3 is the same in parameter and statistic. So we won't have any Greek symbols or anything on this problem. So identify the population. So the population is all 10-year-old boys. Right? They don't put any type of parameter on the 10-year-old boys, like they're from the US or whatever. It just says 10-year-old boys. And so the parameter would be Q3, which would be the 75th percentile. For heights of 10-year-old boys. All right, and then we have the sample. The sample, we have 50 10-year-old boys. And then the statistic is Q3, but this time we actually know the value, is 56 inches. All right, so let's look at part B. A Pew Research Center poll asked 1,102 12 to 17-year-olds in the U.S. if they had a cell phone. Of the respondents, 71% said yes. So this time we've clarified a little bit more as to what we're talking about. So this time it's 12 to 17-year-olds in the U.S. So our population isn't just all 12 to 17-year-olds. It's all 12 to 17-year-olds that live in the U.S. All right, and our parameter. So because they've used a percentage, that tells us that it's P, a proportion. So P is equal to proportion of 12 to 17-year-olds in the U.S. who have a cell phone. Right, and then we have a sample. A sample is the 1,102 12 to 17-year-olds in the U.S. And then the statistic is equal to is p hat, which equals 0.71. All right, so then C, each month, the current population survey interviews a random sample of individuals in about 55,000 U.S. households. One of their goals is to estimate the national unemployment rate. In December 2009, 10% of those interviewed were unemployed. So on this one, I want you to fill it out yourself, and let's check and see if you know what you're doing tomorrow in class. All right, and then D, how much do gasoline prices vary in a large city? To find out, a reporter records the price per gallon of regular unleaded gasoline at a random sample of 10 gas stations in the U.S. on the same day. The range of the prices in the sample is 25 cents. So this is similar to what we did in part B, where we don't really, part A, where we didn't really have a Greek or a statistics symbol. So we just have the same one in this case. So we just have range. So we would have to say what our population is. I have to write small on this one, I guess. All right, so our population is price per gallon of unleaded gas in a large city. All right, and then our parameter is the range of gas prices in a large city. All right, I'm going to have to erase those so I can write some more. So then our sample is equal to 10 gas stations from the large city. All right, and then our statistic is the range, which is equal to 25 cents. All right, so don't forget to do part C so that we can check that tomorrow in class. Make sure you know what's going on. All right, so now let's look at number 2. For each boldface number, 1, state whether the parameter is a parameter or statistic, and 2, use the appropriate notation to describe each number. All right, so Florida has played a large key in a recent presidential election. Remember, our book was published in 2011. So voter registration records show that 41% of Florida voters are registered as Democrats. To test a random digit dialing device, you use it to call 250 randomly chosen residential telephones in Florida. Of the registered voters contacted, 33% are registered Democrats. So we have 41% here, and we have to figure out what population it comes from. So we're talking about all the Florida voters that have registered as Democrats. So 41% is a parameter. So he gets P. And then the 33% of the registered voters, so from the population, 33% of them were contacted. So 0.33 of those are registered Democrats. So you can see that those are the ones that they contacted from the poll. All right, part B. A random sample of female college students has a mean height of 64.5 5 inches, so this one should be bolded, which is greater than 63-inch mean height of all American women. So if we look at the 63-inch number of all adult American women, that's our population. So because we're talking about mean, that would be mu, which means that the sample is x bar, and that would be a random sample of, so that gives us the 64.5 inches. All right? So now let's talk about sampling variability. So sampling variability is the value of a statistic varies in repeated random sampling. So for instance, if we were going to find like the mean of each of our classrooms at the high school, we would have a bunch of different means. Not every single classroom would have the exact same mean if we were talking about like the heights of the students in those classes, right? The classes that were primarily made up of freshmen should have a lower mean than the classes that are primarily made up of seniors. They should have a higher mean. So we're going to find all of these X bars of heights, and they're going to vary a little bit. And so that's going to be some sampling variability among the X bars of heights in our high school. And if you're going to be gone tomorrow, then make sure that you complete these problems down here. The page number is on the guide, and so 1 through 7 odd of those, or just flip to the end of 7-1, and that's where the problems are, and work through 1 through 7 odd.